everybody, greetings from Planet Math, which is where I like to spend my weekends. Today we're going to be talking about using exponents and division. And this goes with both of the learning goals for chapter 12. The first one is I can multiply and divide powers with the same base. Obviously this will be the second part of that. And then also I can simplify expressions with negative exponents. We'll be talking about that a little bit later. A couple days ago, we were exploring what happened when you multiply two powers that have the same base together. And so we did a little exploration with that. I'm just going to kind of show you how it works when we divide two powers that have the same base. So let's say I'm taking 7 to the 5th power and I want to divide that by 7 to the 3rd power. And so remember that when we have exponents, we can, if we want to, expand those out. So I could rewrite 7 to the 5th power as 7 times itself 5 times. And I am dividing that by 7 to the 3rd power, so that would be 7 times itself 3 times. Now when you are having things that are all multiplied together, divided by other things that are all multiplied together, I can cancel out ones that are the same. So notice that if I did that, I could cancel out 3 of the 7's from the top and all of the 7's from the bottom. Because 7 divided by 7 is 1, so I can just cancel those out. And what that leaves me with is 2 7's, which is the same as 7 to the 2nd power. And so once again, we want to notice what is happening with the powers. And what I notice is that 5 minus 3 is 2. And that is the power that I got over here. So this gets you thinking probably that maybe when I divide powers that have the same base, I can subtract the powers. So just like when I multiplied powers that had the same base, I added the two powers together. It would make sense that when I divide two powers that have the same base, I would then subtract the two powers. If you look down here where I have m to the 12th power divided by m to the 5th power, if I wanted, I could write out m times itself 12 times and m times itself 5 times, and I could cancel out all those m's. Or I could just notice that again, I am going to subtract the powers. So that would be the same as m to the 12 minus 5 power. And so then I could write that as m to the 7th power. So I just subtract those powers when I'm dividing. Pretty simple rule. When you multiply, you add the two powers together, and when you divide, you subtract the two powers. In the last video, Yoder talked about how to multiply together two numbers that are written in scientific notation. So today we're just going to talk about how to divide numbers written in scientific notation. We have the distance between the sun and the earth is about 9.3 times 10 to the 7th miles. Light travels about 1.1 times 10 to the 7th miles per minute. So they want us to use the formula distance divided by speed to estimate how long sunlight takes to reach the earth. So my distance is that we know is 9.3 times 10 to the 7th power, and the speed is 1.1 times 10 to the 7th power. So we're going to divide the distance by the speed. When you have two things multiplied together and you're dividing them, you can separate those apart if you want. So I could think of this as 9.3 divided by 1.1, that whole thing, times 10 to the 7th power divided by 10 to the 7th power. 9.3 divided by 1.1 I can just do on my calculator, and that's 8.45454545, repeating, so I could round that to 8.5. Now remember, when a number is written in scientific notation, the first part of that number has to be a number between 1 and 10, and 8.5 is between 1 and 10, so I don't have to do any adjusting here. If it had been either less than 1 or greater than 10, I would have to adjust my power. So now I look at 10 to the 7th divided by 10 to the 7th, and I remember that I need to subtract my powers. So when I subtract my powers, I'm going to do 7 minus 7, which is going to be 10 to the 0 power. So that number is written in scientific notation, so we're done with that problem, but we'd like to understand what that number 10 to the 0 power means. We just want to think about what does it mean if our exponent is 0. So again, remember that if I have powers like this, I could expand those out and then cancel any terms that are in common. So I could cancel those, I could cancel those, and I could cancel those, which is 1. And you can see 7 to the third power divided by 7 to the third power, those two numbers are equal. And so when you divide them, obviously you're going to get 1. However, remembering our rule, we also know that 7 to the third power divided by 7 to the third power is the same as 7 to the 3 minus 3 power, which is the same as 7 to the 0 power. So because those two things are equal, that means that 7 to the 0 power has to be equal to 1. And it turns out, if you check on your calculator, you can see that any number to the 0 power is going to be equal to 1. And the final thing we need to talk about, we need to address that second learning goal. What do negative exponents mean? And to think about this, I want to look at two different examples that will help us understand what negative exponents mean. So remember again, if we evaluate this expression, 6 to the third power divided by 6 to the fifth power, I could rewrite that as 6 to the 3 minus 5 power, which is going to be the same as 6 to the negative 2 power. However, you could also think of our expansion again and notice that this would be equal to 1 because all the 6's at the top canceled out, became 1 over 6 to the second power. So again, that leads me to believe that these two things would be equal to each other. It looks like 6 to the negative second power is the same as 1 over 6 to the second power. So we could say that 6 to the negative second power is equal to the reciprocal of 6 to the second power. If you evaluate 10 to the negative second power on your calculator, you will see that 10 to the negative second power is the same as 0.01. However, if I write that as a fraction, 0.01 is the same as 100, which is the same as 1 over 10 to the second power. And so just like we showed above, you can see that 10 to the negative second power is the same as 1 over 10 to the second power. So it's not that when we have a negative power, we're getting a negative number. What we see is that when we have a negative power, we're getting the reciprocal of the positive power. So it's a little bit different than what you would think it would be. The answer to the free response question today is going to be the name of the planet where I like to hang out on the weekends. So if you can't remember what that is, go back to the beginning of the video and I think you'll find that out. And here are your free response and multiple choice questions. So pause the video, and after that, I hope you have a fabulous rest of your day.